Download this code from codegive.com, link in the description below. Certainly. In the context of distributed systems, the concepts of availability, partition tolerance, and the CAP theorem play critical roles. MongoDB, as a distributed database, exemplifies these concepts well. Understanding availability and partition tolerance. CAP theorem. The CAP theorem states that in a distributed data store, it is impossible to simultaneously guarantee all three of the following properties. 1. Consistency, c. Every read receives the most recent write or an error. 2. Availability, a. Every request receives a non-error response, without guarantee that it contains the most recent write. 3. Partition tolerance, p. The system continues to operate despite arbitrary partitioning due to network failures. In practice, when a network partition occurs, a distributed system can either prioritize consistency, potentially sacrificing availability. Prioritize availability, potentially sacrificing consistency. MongoDB's approach. MongoDB is designed to provide high availability and partition tolerance. It achieves this through replica sets and sharding. In a replica set configuration, one node acts as the primary, handling all write operations, while secondary nodes replicate the data and can serve read operations. Availability in MongoDB. MongoDB offers high availability using replica sets. When a primary node goes down, one of the secondary nodes can be elected as the new primary, allowing the system to remain available. Partition tolerance in MongoDB. MongoDB is partition tolerant, meaning that even if some nodes cannot communicate with others due to network issues, the system continues to function. However, during a partition, MongoDB may favor availability over consistency, depending on the settings. Code example. Let's create a simple example to demonstrate a basic MongoDB setup with replication, which emphasizes availability and partition tolerance. Step 1. Install MongoDB. Make sure you have MongoDB installed. You can download it from the official MongoDB website, https://www.mongodb.com/try/download/community. Step 2. Set up a replica set. 1. Start MongoDB instances. Open 3 terminal windows and start 3 MongoDB instances on different ports. Use the following commands. 2. Configure the replica set. In a new terminal, connect to the primary instance and configure the replica set. Step 3. Inserting data. Now, let's insert some data into the primary and observe how it replicates to the secondaries. Step 4. Check data on secondaries. You can connect to one of the secondary instances and check if the data is replicated. Step 5. Simulate a network partition. To see how MongoDB handles partition tolerance, you can stop the primary instance and try to perform operations on the secondary. 1. Stop the primary. In the terminal where the primary is running, stop it, Ctrl+C. 2. Try writing to the secondary. Connect to the secondary instance and try writing data. You will see an error indicating that you cannot write to a secondary. Step 6. Failover. When the primary goes down, the secondary can be elected as primary automatically. To test this, you can bring back the primary after a while. 1. Restart the primary. In the terminal, start the primary instance again. 2. Check the status. Connect to the primary and check the status of the replica set. Conclusion. In this tutorial, we've explored how MongoDB implements availability and partition tolerance through replica sets. When the system experiences a network partition or a failure, MongoDB ensures continued operation, albeit with some trade-offs in consistency depending on the operations being performed. Understanding these principles is crucial for designing robust distributed systems that can handle failures gracefully.